everyone, today we are diving into a fun twist on data structures, implementing a stack using queues. It sounds a bit backward, right? After all, stacks are LIFO, last in first out, and queues are FIFO, first in first out. So how can we possibly build one using the other? So that's exactly what we are going to discuss about today. Alright, now that we all set, let's get into the actual implementation. In this video, I'll explain the logic behind the basic operations push and pop. So now I'll guide you through the method of making a LIFO queue using two FIFO queues. So to make a LIFO queue using two FIFO queues, we have two methods. The first method is the push friendly method, which is also known as the pop costly method. And the second method is the pop friendly method, which is also known as the push costly method. So we just go through the first one, which is the push friendly method. In the push friendly method, it's easier to do the push operation rather than doing the pop operation. This is why we are calling it as the push friendly method. So in the push friendly method, now as I told you, it is easier to insert or push an element to a queue or a stack, but it's hard to remove. So before we go into this, so F stands for the front of the queue, and R stands for the rear of the queue. So after now we'll just go try to push 3, which is the first operation we have to do. So push in 3. So after we push 3, the stack is supposed to look like this. 3 should be at the bottom. So this is a push friendly method, so where it is easy to insert or add push 3 into the queue. So for this, I'm using two queues known as the push queue and the pop queue. So we are inserting the 3 into the push, because this is a push friendly method. We are mainly using the push queue. So we are inserting 3 into the push queue, 3 as in pushing 3 into the push queue. So after we pushed 3, this is how it looks like. So if we suppose the 3 is in the front of the queue, 3, this is how the stack looks like, and this is how the queue looks like. So now the next one we had to do, this next operation is pushing 5. So we already pushed 3 in, so 3 is already there in the front, and then we are pushing 5. So now 5 is supposed to be on top of 3, because this is the, we are making a last in first out queue, as in a LIFO queue. So in the LIFO queue, the main function is it should be easy to access the top element of the stack, which is the last element we added to the stack. So the last one we're going, so now before adding 5, the top element of the stack is 3, because that's the only element that is there. So now we're going to push 5 to the stack. So then 5 is supposed to be on top of 3. So this is a push friendly method, so it is easy to push 5. So I'm gonna push 5 to the queue, and now this is how it looks. This is how it looks like in the stack, and this is how it looks like in the queue. So the next one is pushing 7. Now 7 is supposed to be on top of 5 because 3 is supposed to be in the bottom and 5 and then 7. So we already pushed 3 and we already pushed 5. We are going to push 7. We pushed 7. So now this is how the queue looks like and this is how the stack looks like. Now 7 is on top, then 5 and then 3. So now we are going to the tricky part, which is the pop method. So this is the push friendly method, so it's easier to push but it's very hard to pop. So to pop there are 3 steps we should do in order to pop the topmost element. This is the first. So there are 3 steps, so let me indicate the 3 steps, 2 and 3. So in the pop function, the main thing is popping the element which is on top of the stack. So right now in this case the element on top of the stack is 7. So we are going to pop 7. When we are popping 7, there's like 3 steps. So the first step of popping an element is to transfer all the elements except for the element which is on top of the stack, which is in this case 7, to the pop queue. So we are leaving 7 in the push queue and we are transferring. So we are 3 and then 5. So now only 7 is in the push queue, 3 and 5 are in the pop queue. So like in the transferring is dequeuing element from one queue and enqueuing the removed elements to the other queue. That is the transferring process. So transferred 3 and 5 respectively to the pop queue. So now 7 is in the push queue and 5 are in the pop queue. So this is the first step. This is the first step of popping an element. So the second step is now 7 is in the push queue. Wait a second. Now 7 is in the push queue, 3 and 5 are in the pop queue. So this is the easiest of the 3 steps we have to do. So in this step we just have to change the names of the 2 queues, because like we are popping 7. So to pop 7, it just doesn't sound right doing it from the push key. So we're just gonna change the names. Now 5 and 3 are going to be in the push queue and 7 is going to be in the pop queue. Okay, so I just changed the names. In this method we're going to change the names. Let me add a note. Change names. Just put it somewhere over here. Okay, now we change. The second one is changing the names. So the next one, now we did 2 steps. The first step is transferring all the elements respectively to the pop queue except for the element which is on top of the stack, and then we change the names of the push queue and the pop queue, which is the pop queue becomes the push queue and the push queue becomes pop queue. So now 7 is in the pop queue and 3 and 5 are in the push queue. Now the next one is we just have to DQ7 from the pop queue. DQ or remove the element from the pop queue. So now after pop 7, it's gonna look like this: 3, and there's gonna be 5. So now this is how it looks like. This is how it's supposed to look like in the stack. 3 is supposed to be at the bottom, and then supposed to be pop. Now we put remove 7. So now there's another pop operation. In that pop operation, we are going to remove 5, which is because 5 is in the top of the stack, which is easily accessible. So we are popping 5. To pop 5, we have 3 steps. 2 and 3. The first step is we should transfer all the elements except for the element on top to the pop queue. So we only have 3 and 5, so we are leaving 5 in the push queue and transferring 3 to the pop queue, because that's the only number we left except 5. So we are leaving 5 on the push queue and transferring 3 to the pop queue. Let me indicate it. So this is how so the second step is to change the names. So 5 is in the push queue, 3 is in the pop queue now. So now we're going to change the names. Change them. 3 is supposed to go to the push queue, and 5 is going to go in the pop queue. Going to be the pop queue. So now this is how it looks like. 3 is in the push queue, 5 is in the pop queue. So the third step is to DQ 5. Third step is DQing 5 from the pop queue. After we DQ 5, it's going to be look like this, and this is how the stack looks. You only have 3. This is how it's supposed to look like. So that's the way I'm going to do the push friendly method. So if I write down the steps for you, the first step is we transfer all the elements respectively from the push queue to the pop queue. And the most important part, except for the top element of the stack. This is the first step, and the second step is to change the names. Change the names of the queue, so it's going to be push queue. Push queue is going to become the pop queue, and the pop queue is going to be the push queue. So this is the second one, and the third step is DQ the element in the pop queue. So we have to DQ the element in the pop queue, which is also remove or pop. So these are the 3 steps we are supposed to follow in when popping an element in the push friendly method. It is easy to pop an element or remove an element from the stack, but it's hard to push an element to the stack. So to push an element to the stack, we have three methods, three steps. So these are the three steps. Like the first method, like the push friendly method, I'll be using two queues. This is the push queue and the pop queue. So this is the pop friendly method, so we'll be mainly using the pop queue. So let's get into it. So we have three major steps. So the first operation is pushing 3. To push 3, the first step we have to do is push 3 to the push queue. You should push 3 to the push queue. So now this is how it looks like. This is the first step. So the second step, we have to have 3 pushed to the push queue. We write this too. Okay, so now we already have 3 pushed to the push queue. That's the first step. So the second step is transferring all the elements of the pop queue to the push queue. Transferring all the elements of the pop queue to the push queue respectively. So that's the second step, but we don't have any elements to transfer here because the pop queue is empty. So that's the second step. So the third step is just like the push friendly method, we are going to change the names. So we're going to change the names. So we're going to change now 3 is in the pop queue and the push queue is empty. So the next operation is push 5. So now we already have 3. Now 3 is in the pop queue. So the first step is pushing 5 to the push queue. So we pushed 5 to the push queue, and we pushed 5 to the push queue. So 5 here and 5 here in the push queue. So we pushed 5 to the push queue. So the second step is transferring all the elements in the pop queue. Transferring all the elements in the pop queue to the push queue. So this before we had 3 here. Now we're transferring 3 to the push queue. So 3 is here. Now the pop queue is empty. So this is the second step, and the third step is changing the names. So we pushed 3 here. The third step is changing the names. Pop queue, push. So now we change the names. So the second operation is pushing 7. So let's do that. Now we have 5 and 3 in the pop queue. We're supposed to push 7. So the first step of pushing 7 is push 7 to the push queue. That's step 1. Now the step 2. For the step 2, we are gonna write 7 over here. For the method step 2, we are gonna transfer all the elements respectively from the pop queue to the push queue. So when we transfer 5 and 3, we have 5 here and 3 here. So we are transferring from the front of the pop queue. This is the front. We transfer elements from the front to the back. Then we are inserting them from the back, because that's how the FIFO queue works. So we are supposed to make 7 on top, then 5, and then 3. So now it looks like the 7 is in the front, then 5, and then 3. So we get this. So the third step is changing the names. So we have 5 here, 3 here, and the pop queue is empty. So now we are going to just change the names. Now change the names. So this is how it's supposed to look. Now this is how it looks like. Now we're going to pop an element. So this is a pop friendly method. We can pop an element within one step, because that's the easier thing. So in this step we are popping 7, because as I told you before, 7 is on top of the stack. So the top of the stack elements going to be eliminated or removed from the stack. So when you pop the element, the stack's gonna look like this. Because we removed 7 from here. We removed 7. No, there's no longer 7 here. It's gonna be 5 and then 3. So like, we do another step and go and pop this is how it's supposed to look like. And we pop 7. Now the top is 5 and then 3. So if you pop 5 from here, we can just pop 5. So then the stack is going to look like just 3. So if you pop 5, the 5 is going to be gone, and then it's just 3. So yeah, I'm going to write the steps. The first step is pushing element into the push queue. Pushing the element to the push queue. The second step is transferring the elements respectively from the pop queue to the push queue. So the third step is changing the names. So the pop queue is gonna be the push queue, and the push queue is gonna be the pop queue. So these are the 3 basic steps first we take this one. First we are going to push 5 to the push queue, and then we are transferring all the elements respectively to the push queue from the pop queue. So 3 was in the pop queue. Now we transfer it to the push queue, and then the third step we just have to change the names. That's the 3 steps. So now that you understand the logic behind building a stack using queues, let's get into coding. So I'll be doing this in Java, but the logic applies across all the languages, so feel free to follow along with whatever you like.